So you see this success message, right? The one thing that tells your user, hey, everything's good. But what if that message was a complete lie? What if, hiding behind this friendly green banner, the entire user interface was actually totally frozen solid?
Yeah, this success message was fake because the actual system was already deadlocked. All right, let's dive into this real production bug story.
Okay, so to really get what went wrong here, we have to put ourselves in the user's shoes. They're just trying to do something simple, change their plan. But for them, this little task turned into a seriously frustrating journey.
So here's the play-by-play. The user picks a new plan, and the system correctly throws an error banner. Hey, this product is incompatible. No big deal. The user sees it, they get it, and they pick a different compatible plan. They've done everything right. And then nothing. Just crickets. No success message, no confirmation. The UI just sits there, completely unresponsive. I mean, can you imagine how confusing that is?
The user corrected their mistake, but the system just wouldn't forgive them. And this right here is the moment a tiny little UI bug starts to snowball into a massive business problem.
Now you might be thinking, it's just a missing message, what's the big deal? But in a live production environment, that kind of silence is incredibly expensive. We're not just talking about a glitch, we're talking about a complete breakdown of trust between the user and your product.
And this is where you really see that ripple effect. First, the user gets confused, right? Then they lose trust. They think the whole system is broken. So what do? They either just give up and abandon their order, that's lost revenue, or they pick up the phone and call customer support, which drives up your operational costs. Either way, user satisfaction tanks, and the business feels it. So yeah, this wasn't just some bug, this was a high-priority fire.
So it was time to start digging. Our first stop was the client side, right inside the browser's DOM, to figure out why our UI was giving users the silent treatment.
So what was actually going on under the hood? I mean, why would an error message completely stop a success message from ever showing up?
Well, the root cause turned out to be something we started calling ghost banners. See, every single time an error popped up, the code was creating a brand new banner element and just slapping it onto the web page. The problem? It never cleaned up the old ones. They were just sitting there, invisible, stacking on top of each other like invisible pancakes, and literally, physically blocking the new success banner from ever being seen. It was a classic UI deadlock.
With every error, a new banner was being created. The old one never died, which meant there was just no room for the success message. But, just fixing the UI? That was only half the battle. The real problem, the deeper one, was architectural.
And for that, we have to look at the server. See, any stable system needs a single source of truth, and our UI was basically writing checks that the server couldn't cache. That is a cardinal sin in system design.
And this is probably the biggest lesson here. Validation is not the UI's job. Your business rules have to live on the server. Otherwise, your system is telling lies. The client side should only ever be a mirror of the state that the server has already confirmed.
So the right way to do this is to have one central service on the server calling all the shots. And for that to work, it can't just get a simple request. No, it needs the full context. What kind of order is this? Which account are we talking about? What's the promo code? All the juicy details it needs to make an intelligent, authoritative decision.
And this is how you build a smart, performant backend. It uses what you could call conditional gatekeeping. It doesn't just run that heavy validation check for every single request. No way. First, it does some quick checks. Is the product even relevant? Is the order type something we care about? Is this a special Bajaj-linked account? And only after all those boxes are checked does it bother to run the expensive, deep compatibility check. It's all about preventing wasted work and keeping the whole system snappy.
So, with the server logic now much smarter, we went back to the UI with a brand new philosophy. The goal wasn't just to patch the bug, it was to change how we handled notifications entirely. And the fix was beautiful, really. Recycle, don't recreate.
I mean, just look at this comparison. The old way, create and destroy, meant we were constantly adding new stuff to the page. It's messy, it leads to memory leaks, and as we saw, it causes all sorts of conflicts. The new way? So much cleaner. We have one single permanent container for our messages. We don't create or destroy anything. We just manage its state by swapping out a CSS class. And we properly clean up our event listeners so we don't get these weird stacked up click actions. The result? It's stable, it's efficient, and best of all, it's predictable.
So the key point is this. We didn't give the UI a memory. We gave it discipline. It now follows a strict, clean, and repeatable pattern for every single message it shows.
And really, this is the magic right here. Instead of all that complicated DOM manipulation, the entire UI fix boils down to this one simple action, swapping one CSS class for another on the exact same element. From error to success, just like that. So clean.
All right, so with both the intelligent server-side fix and the disciplined UI fix now in place, we could finally step back and measure the real-world impact. It was time to turn this production defect into ancient history.
And honestly, the results speak for themselves. Architecturally, we upgraded to a much more modern, state-managed model for the UI. The defect itself, completely gone. The UI also became way faster and more stable because we cut down on all that DOM clutter and those memory leaks. And, this is a big one, we managed to do all of this without breaking a single piece of existing logic that other teams had built. A huge win.
One small design change, a little shift in philosophy, and a critical production defect became nothing more than a story we tell.
And you know the best metric of all? The number of UI deadlocks reported in production since this fix went live? 0! A big, beautiful 0!
So, what's the big takeaway from all this? Well, a simple UI bug is often just the tip of the iceberg. It's usually pointing to a much deeper architectural problem. If you fix both, you end up with a truly robust system. If you enjoy breaking down real production war stories like this one, and not just watching polished, perfect world tutorials, make sure you subscribe for more. I'll see you in the next deep dive.